So, we have one last case left, which is when we have two children. We have a bidar derp, and we can actually have a maximum of two of them in total. And again, as you can clearly see, we will have two bamboo shoots stretching from the bottom in this example, which is quite fascinating, once and twice. And here we essentially have three options for how to finish this whole thing. Essentially, basically. The first option is to let us go along the tree, one path through the bamboo. We carefully cut this bamboo and we pull this one further with precision. This is the first option we have available to us, and it is a method we often use. The second option, we, on the contrary, break off this bamboo, finish it, while this one goes further up. Next, we have an option where both bamboos are cut off, and we go up with a new one. This means that the old bamboos are completely removed and replaced with a fresh new bamboo. So, what was the last option we discussed before this one? The last option was that we create a new bamboo, while these two are merged into one, and we make something like this new one. It's absolutely beautiful. So, what we have here are purely four distinct options available for the transition process. Well, accordingly, what will our regular formulas be for two vertices? You might be curious to know more about. That is, in essence, we are currently considering which various available options and potential options carefully because, well, first we need to find the minimum value for child 1, which involves a detailed process of evaluating all possible options and selecting the smallest one. Similarly, we must also determine the minimum value for child 2 by going through a similar thorough evaluation. This is crucial because ensuring that we have the minimum values for both children allows us to make the best possible decisions moving forward, considering all relevant factors and potential challenges. Here we are considering the possible cuts in detail. That is, we are thoroughly examining the case when we cut this bamboo. Which different cutting option would be more advantageous for us? With which potential fur that we would have extracted beforehand? Carefully considering the possible outcomes. We also create another minimum. This is simply the minimum when these two bamboos essentially merge into one. We can also choose.
Want to become a great programmer? Subscribe to our Telegram channel.
So, there is no third vertex here. It will be like this. And that's how it is. It is important to understand that here, J will be iterated independently. That is, we are iterating our own XOR here, and here we are iterating our XOR for J. Here, J must also be the same, meaning that the current XOR for both variables must be identical, which is why J is added. Well, accordingly, all of this works only if J is not equal to AE, because in any case, we have to finish with this Babukin A there. If it doesn't suit him, then all of this doesn't suit. That is, it is not equal here. Essentially, fundamentally, and ultimately, we end up with the minimum in the end, basically, essentially. This situation has arisen due to a variety of unforeseen circumstances and factors that were beyond our control. This is due to the fact that the value of v3 is determined by the combined sum of both v1 and v2, which are added together. These values are summed up to give the final result of v3. When both are truncated, we pull a new one from the available options, ensuring continuity. Then, we leave two cases where one is truncated and the other continues to operate as expected, maintaining the process flow. At the same time, J will also be iterated here. This means that J will operate independently of these three values, ensuring that each iteration is unique and unaffected by the others. This means that we do not necessarily have to interrupt this mechanism and continue further. It is not necessary for these two, to have the same for J. It can be different. So, well, In essence, fundamentally, this is where the whole task takes place, and in this specific area. In the end, and ultimately, we will simply and straightforwardly output the final and conclusive answer. We will also translate J and take the minimum from what we have read in order to gather the necessary information and details that are required for our vertex of the entire tree. Here, there is no need to check that it is not equal to item, because if it is equal to item, it will simply be infinity. That's all. In summary, essentially, this is basically the whole entire task. So the main joke here was this, because if we had known this from the start, I think we could have tried to come up with something and finish it on Saturday. But without this trick, the task is, well, not for 3000 it seems to me. I think, in my opinion, it definitely, without a doubt, shouldn't be there at all. But how will it be different for us in any way at all if we are traversing a square? Before we traverse the XOR for the current vertex, we traverse it for the previous ones. And what about Jane and Force? What is XOR? The mech we have is Jane, and we are traversing the mechs for the previous vertex. Here we are just finding these three mines, and we are checking all the mechs. Oh my. Yes, and in one formula, there should be the same. In one formula, J is generally speaking the same, while in the context of different ones, it is different. A small clarification for vertex 1. The smallest formula is just being shortened a bit more. We can't drag this matter out any longer. Our mech is running out here and now. Therefore here we take the minimum. In this particular case, as the optimal choice. Well, after careful consideration, we decide whether to combine the mechanical parts into a single unit or to complete them as separate entities for each of the two children. This decision is based on various factors, including the specific preferences and needs of the children. So, accordingly, if we have vertex 1 alone, meaning child 1, vertex 1, then we can only consider the case when we finish our mech. Yes, we are traversing, and we will finish the mech if we already have the vertex of the entire tree. This is impossible for one.
Want to become a great programmer? Subscribe to our Telegram channel.